In the upcoming video, I will show you guys how to heat up your house or your greenhouse for free. Literally, we did that, and I want to show you the numbers. So basically, it's not composting. It's something way better than composting. And look, so from 120 pounds of organic matter, and I will show you the videos in a moment how it works. I will show you the machine. So from 120 pounds of organic matter, and let's say that's 54 kilograms in like metric, okay? So we manage daily or like hourly, it doesn't matter, just check the ratios. From that amount we manage to make 360 kilowatts of heat. The advantage compared to composting, it's rotting, nothing has like the bad odors. You don't have to clean the machinery. Yeah, sure, you have to put the materials in it, but it's like really clean. It can be used as hospital level of killing bacteria or like eliminating viruses. So it's extremely good. So probably you know about hot composting and cold composting, and that's something kind of a different. It's not composting. Let me show you the machine for a second. I made 3 versions, none of them look alike. They don't even are like related to each other. But the main idea is to get the logic, and if you have like the logic, the chemistry, how it works, you will be able to make your versions and you will be able to decide, oh, I want to do it this way or another way. So for first, I don't want to show you the machine or machines like the versions that I made. I want to show you like the logic, how it works, and afterwards we'll discuss what was the pros when I made and what was like the negatives and how to decide, you know, if you want to heat up your house, you will, with compost, you make one version. However, this is not compost. If you want to heat up your greenhouse, then you use maybe another version. But let me show you like the math. So the catch was here. When we turned the compost, the cold compost, when the cold compost started to heat up, let's say, and it's become hot compost. Everybody knows that. I'm not telling nothing new. However, the problem was the following. Everybody figured out that the compost will die down like the temperatures after like 2 or 3 days. And the issue is that the person, if you don't turn it, it dies because the bacteria that it makes like really hot, let's call it thermal bacteria, it will die because one, it will overheat, so they will kill themselves with their own heat. The second problem, they will die because they don't get the oxygen. Yeah, so everybody know that. And the third one is they don't get water. So basically they need water. And here's this issue. What was the problem? So when you turn the pile, you cool down the pile, so the thermal bacteria dies on the instant. They die. So you don't want to kill them. The second problem, if you open the compost pile, the water will evaporate and basically the bacteria won't have the water. Third, if you put water in it, you will kill the thermobacteria again. So there's an issue. And the whole thing, like the whole machinery that we built, is doing nothing else. It just keeps the thermobacteria alive. Thermobacteria starts to live at like 130 Fahrenheit, 54 Celsius, and it dies at like 155 Fahrenheit, 68, 69 Celsius, something like that. So the main idea is we need to keep the temperatures here. If we go below that, the thermobacteria dies on the instant. And what's the benefit of the thermobacteria? Basically, they are decomposing way faster than the bacteria that it's like the cold composting bacteria, like the mesobacteria. And they decompose other bacteria, they not kill, they eliminate the viruses because the viruses are not living. And basically they give us like way more energy than with other methods. We have other benefits as well. For example, we won't have like the harmful gases like the laughter gas. We won't have the methane that we don't want. We won't have the rotting. So how you heat up your greenhouse with compost? So again, with the hot composting, check the numbers. So with the hot compost again, now I'm talking about the hot composting, like the ideal version. So from 120 pounds of organic matter, let's say 54 kilograms, to provide the oxygen for the thermobacteria, like the aerobic thermobacteria, you need 237 or like 238 square cubes of air. That's a lot. So when you turn the pipe, you won't provide oxygen because you turned it, and afterwards it's closed again. So they are not oxygenated. Like, look, the difference is like huge. So you need like extraordinary big amounts of oxygen for the bacteria. Like, think about when you're running, you need a lot of oxygen. So the bacteria do the same. So if you want to get heat, you have to provide oxygen. Like with fire, you can't have a fire without the oxygen, isn't it? So the bacteria works like the same. Look, near it was the big number, 466, and what's that? That for me it was like really strange. It's not the oxygen the problem, because okay, they get the oxygen, they found it somewhere, they have it. But the problem is the CO2 will kill the bacteria. It's like the same with humans. If you are trapped in an enclosed room, let's say, the lack of oxygen won't kill us. The CO2 will kill us like 10 times faster than the lack of oxygen. We need to build a machine that keeps them in a warm condition and eliminates the CO2 and provides them with oxygen, isn't it? And there's a catch. How can we give them the oxygen and eliminate the CO2 in a way that they get the air that's what's not with the air? It's not cool, because if we cool them down, they will die. So yeah, it's a contradiction in a way, you know. So look, you make the machinery and you insulate it. You insulate it because if you're not insulating it at first, when the mesobacteria, like the normal composting bacteria, starts to work, they are not that efficient and they don't produce a lot of heat. So you have to insulate it because you want to get the temperatures up fast. Let's say like a 15, 20 centimeters of insulation, that's like 6 inches, something like that, 6, 7 inches, air 30 or like more. It doesn't matter because probably it will heat up, but you like really start to heat it up, you know, like you give it like a head start. So you close the whole machine, you don't give air, because if you don't have composting, look, like the thermal bacteria starts to work at like 125 degrees, like 51 Celsius. You don't need air, you just close it. You like close it, nothing gets in, nothing gets out. And you start to measure the temperatures and you wait, you know. And after, when it starts to reach to like, or you can give basically, now I see my notes. So basically you can give them like at 115 Fahrenheit, like 46 Celsius. You can give them like a small quantity of air. Let's say like with a little ventilation system like that, you know, like or a little fan, you know, like just like that you can ventilate a parrot, something like that. And afterwards, when it starts to reach like 125 Fahrenheit, like 51 Celsius, then the pathogens die, you know. That's like when the thermobacteria starts to eat everything, you know. They kill the pathogens, they eat up the bacteria, they start to decompose the viruses. And here they were, I'm not really remembering, but if I know, I think they are like 20 times more efficient to decompose things like the normal bacteria. I'm not sure here, but if I remember it well, it was like something like that. And here, basically, they will do a lot of work. They will decompose everything, you know. And here you need to start to give them air, but slowly. And here's another catch, because at first they start to produce heat, but they are not like really, it's not like a furnace in the inside. And when you give them the air, I will tell you about the air in a moment. When you give them the air, you have to preheat the air. So let's say you have like the machine. I'm showing, wait a bit, I show you the machine now. Okay. So let's say this is the machine. And on the upper part, I make like a piping, you know. I made pipes with like 20 centimeters diameter, like 15. No, it was 15, like 6 inches. And I put on the pipe in it like maybe 6 meters long, like 3 times my height, something like that, 3-4 times. And the cold air that I'm pushing in the inside, even if it's the summer in the outside, it's like really hot, then it's not hot enough. So if you let the air to circulate on the upper part of the machine, or like you put a pipe in the inside, the air will be warmed up. So this way you can manage the following. You're not cooling the thermobacteria, and that's the main idea. It's not the problem that you're not giving them enough air, and probably it won't be a problem that you're choking them with CO2. Those won't be a problem. That would be like the smallest problem. Your biggest problem will be that you will like kill them with cold air. So the second you open the door, you know, you just say, oh, let me see what's happening, or like, oh, let me open it to just see the temperatures with like a laser beam or something. No, you don't do that because you kill the bacteria on the spot, you know. They're like extremely sensible, the thermobacteria. If you just open the door and it gets down the temperature, you like kill them on the spot. It's like, I'm exaggerating here, but it's like that. So if you're, how they say it, if you're cooking, if you're looking, you're not cooking. So how to heat up your greenhouse? This way, it's like clear. So look, from 400 pounds, like 181 kilograms of organic matter, you will have like 1,055,000 watts. I think it sounds great, isn't it? So, and you have like two options to heat up your greenhouse with compost, or like how to heat up your house with compost. Basically, the one option that you get the air from the composting chamber and you push it directly to the greenhouse, and it won't, because it's nothing is rotting here. It's like aerobic, it's like oxygenated. uh, it won't have like the rotting smell, it won't have the laughter gas, it won't have like anything bad in it except the CO2, of course. And the other version is you put like water pipes in it and you start to circulate the water and you take out the water here and there, you know. You can heat up your jacuzzi, you can put your heating system on the house on it. So you have like a lot of versions, or like maybe in the morning when you want to heat up the house with composting in the morning, it's not like you have like 100 liters, 200 liters of hot water, but here you can leave the pipes in the compost itself and they heat up like in 5 minutes, 10 minutes, and afterwards you can heat up a huge jacuzzi like on the spot. So you can use it in the mornings, for example, when you have like 10 kids and like 7 wives and you want to take a shower everybody at once, and you can manage it with this system, you know. It's not a problem because you just leave the water in the pipes for a few minutes or like for 15 minutes and you will have like hundreds and hundreds and hundreds of liters of 65-degree like hot water. So that's how you heat up your house with compost, or your house, because why not? If you have like a bigger house and you have like a garage or you have like a workshop, you can heat up the workshop with compost. Like, why you shouldn't? Because again, I made the, wait a bit, I'm showing you again. So look, I use grass. If you look at it, it doesn't look like, yeah, it's not like you're not like in a restaurant and it's not like you want to eat it, but it's nothing, it's like having like a bad odor that will kill you. It's nothing like, it's nothing, it's rotting, you know. Actually, it will sterilize everything. You can put, if you put some food in it, you will say I'm insane here, but if you put food in it and you leave it like there for like a day or like even more, it will be ready and you will be able to eat it. Because look, at 65 degrees or like 60 degrees, the food will start to cook or bake, or I'm not sure about the wordings here, and the vitamins will remain in the inside because you're not breaking them down, you know. And because it has time to cook, it will be like way better if you would if you would do it in like 5 minutes. The slower you cook it, the better will be. Like the brisket, you know, they are making it for like a day or something, you know. They're not making it in 5 minutes and they say it's superior to other kind of meat. Because so I heated up the house and especially like our basement, because we have a huge basement, and I used the pipes. I didn't try it like with hundreds and hundreds of houses, but I can tell it's working like really great. Look, I'm showing you another video in our basement. So look, in the outside it was like winter. I live in Europe, like Hungary zone, and it's like really cold in the winter. So it was like, it was ice in the outside. I don't know in Fahrenheit, but it was like a -6 or -7 degrees. So that's way below zero. And I had like, look, and I had the pipes in the outside. Basically it was like 15 not 15, like 7-10 meters, something like that, from the machine to the measuring device when I'm measuring it, and it wasn't insulated, you know, because I didn't want to heat up the house with these videos. I just wanted to see like, oh okay, I wanted to check, you know, so I didn't insulated the pipes at that level. And look, it's 27 degrees, 28 degrees Celsius, and it's like the CO2 is coming, because the byproduct is the CO2. So you have that. So again, it's extraordinarily good with greenhouses, but I wouldn't use the air in the composting air in the house as well. So for first, like it has an odor, so it's not rotting. It's not like you will faint from it, but it has CO2 in it, you know. So you wouldn't use that directly. If you have a house, then you're heating up the water. You put the pipes in the compost, you heat them up, and from the heat, basically you will make a system that will heat up your house, but you're not using it directly. However, in the greenhouses, you can put it, like you can use the compost for the greenhouse without the problem. And look, here I just probably I was like going up because I was like changing something in it, and that's why the CO2 level started to go up and up and up, you know. So that's it for now. That's how you heat up your greenhouse with compost. And actually that's not compost, but you can heat it up, and it's way more efficient. It doesn't have the odors, it doesn't have like the bad smell. Okay, it has the odors, the bad smell, but it's like 100 times like better than with like the normal composting in the greenhouse. And that's it. If you want to ask a question, just ask me. And if you want to build it, like contact me, because I have like a longer Excel sheet that will help us to navigate, you know, how to do it, because it's not that simple. It's not that simple. Oh, you just have the pipe and you put like a ventilation system on it and it will work. You know, actually you have to calculate it, you know, like the CO2, the oxygen and all of it. For example, with my machinery, I had my calculations, and for me it was one ventilation, like one vent with like 300 square cubes of air per hour for the intake, you know, and I had another one with like I think like 200. It was something 200 square cubes of air that was like the outtake that I was grabbing out the air from the inside. So I have those, and I have the machinery, but basically that rotated it. But you don't have to rotate it all the time. You just put it to rotate in every like few minutes. And the other version, that was like my third version that you can see on the, wait a bit, I'm putting it back. So the machine itself is static, but the arms rotate. And it has like the weaknesses of it. I won't speak about those in the video, like what's the pros, what's the cons for the versions. I'm just showing here that's the static version, where the machine is static and the inside moves. And I have like another version where like the whole machinery moves, and the like that's basically there the whole machinery moves. And I think it's not better, it's not worse, it's different. And if you guys are interested, and I will make another video showing the other two machines as well that are working totally different. And here this machine is like almost empty, you know. I didn't make a video when it was full. I had a design or like an engineering mistake, and I needed to make like a modification that you don't see that on the video, but after the modification you can put like 4 or 5 times material in it. And basically that's it for today's video. And if you want to build it, just drop me a line and I will help, you know. I want to make sure everybody will be able to heat up their house or heat up their greenhouse with in a sustainable way, you know, with sustainable methods, with compost or like this. I'm not sure if it's composting, because it's not composting, because most of the things will decompose and they will go back to CO2 and to energy. So you won't have the byproducts, you won't have the humus or the earth. It will decompose things way better, and most of the things will leave the chambers like in form of CO2. So I don't say like nothing will remain there, but compared to like normal composting in a greenhouse, you won't have like the byproducts. You won't have like stored like the laughter gas. You won't have like a lot of poisonous gases, except the CO2 of course. And basically that's it, and the pathogens will die. So subscribe to the channel, and if you're like interested, drop me a line and ask a question, or just like call me and I will show you how to do it. And if you want to build it, I will help you. Okay, thank you. Subscribe to the channel, and that's for today's video.